guys, welcome back to Girl of Coders, and today we are going to take a deep dive into the most common data structure, that is stacks and queues. And so yes, it forms the foundations of many complex algorithms, and it has a lot of real world applications as well, and it's also used in many scheduling processes in an operating system or like managing browser history. So understanding how they work is crucial, especially if you are dealing with coding interviews or learning the basic computer science fundamentals. So by the end of this video, you will be having a clear understanding of what stacks and queues are. Second, how to implement them in Java. And third, the core operations of both. And also some real world examples. Yeah. So to begin with, um, what is basically stacks? So first, let's talk about stacks. So a stack is a linear data structure that follows the principle of LIFO, and that stands for last in first out. And like imagine that you have a stack of books on your desk, and the last book that you placed on the top of the pile is the first one you take. And when you need to grab a book, so you will be taking the first one out from the stack. So this is how stacks work. You take the last that was put in the first time out. So you can also visualize this, like suppose you are pushing three books in a stacks, and this is book 1, this is book 2, and this is book 3. So when you're starting to remove the books, the book 3 comes out first, then book 2, then book 1. So the last one is the first one out. If I am pushing it from here, so the last one, that is the third book, falls first. And let us discuss some core concepts of stack, like core stack operations. So what are the key operations you can first perform on a stack? So we mainly have the four like essential operations, that is first one being push operation, push. Second one is the pop operation. Um, Third one is peak operation, and the fourth one being um, is empty. So the peak operation is also called as the top operation. So what is the push operation? The push operation adds an element to the top of the stack. So if we are having a stack, like let's visualize a stack of books, and we are like putting them all over one after another, and so this insertion is known as the push operation. And the next one is the pop operation. So this removes the top element of the stack. So this one was push, this one is pop. Next one is peak or the top. So this allows you to look at the top element without removing it. So if you want to check that which element resides in the top of the stack, then you would be doing top or peak. And the last one being is empty. So what is the function of is empty? It checks whether the stack is empty or not. So you can guess it from the name itself that is empty means is the stack empty or not. So I would like to show you the implementation, and yeah, so if you see here, if you want to implement stack using queues. Oh my god, is my screen recording? It's not. Yeah, so let us take an example. Let's take this question, implement stack using queues. So we want to implement stack using the queue operations, and we need to perform the normal functions of a stack, that is push, top, pop and empty. So the functions that are given to us are void push int x, int pop, int top and boolean empty. So what we be doing in the function void push int x, we would be pushing the element x to the top of the stack, and in the int pop we would be removing the element on the top of the stack and we would be returning it, and in the int top we would be returning the element on the top of the stack, and in the boolean empty we would be returning true if the stack is empty and false otherwise. So uh, let us see the example. So the first thing we need to do is forming the object of my stack. Then we will be pushing the first element, that is 1. Then we will be pushing the second element, that is 2. And then we will be performing the top operation. We will be finding that which element is at the top of the stack, and we need to do the pop. We will be moving the element 2, and then empty. We will be checking if the stack is empty or not. So yeah, let's come here to the solution. So first we would be forming the queue, that is q1, uh, that is of integer type. Then we will be forming the q2, that is again of integer type, and as we were said to do here, and then we will be forming a linked list q1, then q2 again. So these are the stacks. and public void push. What is this function doing? This would be adding the element x. Next is public info, and here int temp is 0. Like we are taking our temporary variable temp and initializing it to 0, and then in the while loop we are checking if the first queue is empty or not. So temp q1 dot peak, and then q2 dot add q1 dot float. Okay, so then we are initializing this, and we are adding q2 dot 4, and then we will be returning the variable. So we will be popping out the variable, the element, and to check if the which element is at the top of the stack, you would be doing this while loop, and we are checking that it's empty or not, and then the operations we are doing here, you can check them, and this is how we are getting the top element. And next is public boolean empty. So we are checking if the stack is empty or not. So we are checking the size of the q1 is equals to 0, then we will be returning true, else it would be coming out of the if condition and it would be returning the value false. So this is how we implement stacks using queues. Alright. Alright, then let us move to the real life application of stacks. Um, Real life applications of stack. So what are the real life applications of stack? So first one being the undo and redo operation. Undo and redo operation. So while using the text editors, we must have done undo or redo. So what? So how is it done? What's the idea behind that? So the stack is keeping with it the most recent value, and we can do redo with the help of that, and undo deletes the value and keeps it in the stack. Next one is function call stack. Function call stacks. So what happens in this case is, like in most of the programming languages, the function calls are managed using a stack, and which helps keep track of which function is currently being executed. And also in balanced parenthesis, so like we often use stacks in checking if an expression has balanced parentheses or not, like in a mathematical formula. So these were some of the real life applications of stack. Next is queue. Yeah. So what is basically queue? So operations in stacks, basically it is following the last in first out operation. But in case of queue, we are doing first in first out. So queue follows FIFO structure. Um, so in case of queue, there is FIFO, first in first out. So like a queue is just like a standing in line for your favorite concert tickets or at a coffee shop. So the person to get in line is the first one served. So if I am standing in this queue and I need a coffee in my canteen. So if I stand here first, if I come in the queue first, so I would be getting served the first. So next is we can also visualize it if like we are adding elements 1 to 3 in a queue and then we are like removing or dequeuing it in the same order. So first 1, then 2, then 3, like that. So I would like to discuss some of the core queue operations. Um, core queue operations. So first one being enqueue, that is adding an element to the back of the queue. So you can just remember that queue has four core operations, four operations, namely enqueue, it adds element at the back, add to the back, and next one is dequeue, that is removing from the front of the queue. Removing element from the front of the queue. So yeah, next one is peak operation, and it's also called as front, peak or front. And like it looks at the front element without removing it. Look at front element. Yeah. And next one being is empty again. It checks if the queue is empty or not. if empty or not. So what is the queue implementation in Java? As I have showed you in the first example, you can go through that. In that, I showed how the queue functions are operated and how we can do the stack operations using two queues. Yeah. So I would now like to discuss the real life example or the real world applications of queues. Real world application of queues. So first one, like Q has a lot of real world examples, and we can name it like um like in case of process scheduling. Process scheduling. So what happens is like in operating systems when tasks are scheduled for execution, so they enter a queue and they're processed when the order arrives. So, in case of process scheduling, all the tasks are in queue, and so it's their order, and when their turn arrives, the tasks are done in operating system. Now, it's also used in breakfast search, uh, BFS. So what happens is like in graph algorithms in BFS, nodes are explored level by level using queues, and also while printing queues, um, printing queues, what happens is when we send a print job to a printer, it enters a queue and is printed in the order it was received. So this is the application of queue data structure, and now I would like to differentiate between the two, the stacks and the queues. Stack and queues. So basically I would like to summarize both stack and queue. So I can do it feature wise. Listing here the feature. So the feature being insertion, how insertion is done. So in case of stack, push to the top, top, and in case of queue, enqueue at the back, back, next one, removal. So pop from the top, and in case of queue, dequeue from the front. From I would also like to mention some of the common uses, like they both can be used in performing undo operation, function calls, scheduling, um, and like BFS. So stack work the best when we need to reverse the order of the elements, while queue are perfect for processing tasks in the order they were added. So to wrap up, both the stack and queues are like essential data structures. Like they are widely used in different areas of computer science and like real world applications. And I hope that this video was helpful and you were able to grasp the key concepts. And if you have any problem, you can comment down in the comment section